What's up, YouTubers? So in continuation with my 60-10 videos I've been putting out lately, I'm going to do not really a comparison between rods, but I'm going to show you a couple ways you can run these rods. And it's somewhat of a controversy, like in the welding community. People say no whipping, some people say whipping is okay, and by whipping I mean like manipulation of the electrode. I can tell you with 60-10, like it functions better when you actually do a movement, and the whole purpose of it, really, the rod itself, it really works great when you're trying to bridge a gap, because by whipping out of the molten puddle and then back into it, you can stack metal on metal because you're using how fast that weld solidifies as like a platform to put the next chunk of weld on or the next molten pool. So manipulation is part of the rod. I mean, it's why a lot of guys use it, especially for pipe. Although, I mean, on pipe, you can do straight in too. But we're going to compare the differences between just going straight in. And I'm going to show you a couple different ways you can manipulate the arc. We'll have arc footage, a lot of comments by me. Some, a lot of this is kind of an opinion, and it's my opinion. I'm not saying that it's right for every circumstance, and I'm not saying it's right for you. I'm just going to explain what a lot of guys do, what I do, and show you the footage so you get an idea of how you can use manipulation to help you out with your welds. So let's get into it. So there's a lot of ways you can manipulate 60-10. I'm going to show you here very commonly, especially in the uphill position when you have a gap. Now, I'm exaggerating this. I mean, this is probably almost a ½ inch here. But when welding uphill or welding a gap, when you come in here and you get a molten pool and you bridge over, and then you bring the rod forward like maybe a ½ inch, 3/8 of an inch, the metal that you just laid down there that bridged the gap will cool. And then when you come back in, you're going to deposit more metal again, and then you can step out of it, or you can actually long arc it, which then allows that puddle to cool, and then you can stack metal. So 60-10, especially these red rods, which freeze really fast. If you watch my video called Intro to 60-10, you'll see actual comparison arc footage of how fast this freezes compared to most other 60-10. So it's very important, I would say, if you watch it, you get a better heads up of what I'm talking about. So anyways, doing a stitch motion or like long arcing it slightly will allow you to bridge a gap and deposit metal and allow the puddle to cool. Now there's a limit. When you're talking this wide of a gap where it's bigger than the rod with the flux, you're still going to have an issue bridging that. I mean, you would either need to use a bigger rod at lower than spec amperage to try and bridge that, or you'd try and close the gap up a little bit. I mean, for most of you, once you get pretty good, an 1/8 inch rod, 60-10 will bridge an 1/8 inch gap no problem all day long, pretty easily too, mind you. Keep in mind, like if people are doing plate welds like this or on pipe, they bevel it and they generally run a slightly tighter arc, but you can bridge this. Just, you're not going to get full penetration all the way through, but you will weld them together. So anyways, let's talk about a couple methods that you can use. I personally, when I'm welding with 60-10, I will strike the arc, and then I tend to step forward, back a little bit, pause, step forward, back a little bit, pause, and that's how I generally run it. However, one thing, and you're going to see it in the video, that's what it looks like, you can't tell what I'm actually doing beyond it. It's going to look like this, okay? I tend to rock the rod up slightly, and when I come forward, I'm actually pushing the rod into the plate like this. And I'll even demonstrate. This will probably, let me get it to focus. So I bring it up, and then I'm trying to dig into the plate, okay? That's kind of what you're going to be. You won't see it because the rod, it'll look like it's just touching the plate. But that's actually what I'm doing. When you set the arc force, if you have adjustable arc force on your machine higher, as that arc gap gets smaller, it boosts the amperage up, okay? Well, you can really use this by doing that kind of a manipulation to dig into the plate. And that's what the whole purpose of 6010 is really to get really good penetration. And how you do that is using the arc force control to your advantage and really cramming it in there. So that's something I do. You also have the capability, and it works good, of you can step forward, you can bring the arc, and this is exaggerated, but you bring it up, down, forward, up, down, forward, up, down. I find that this manipulation gives you more of a stack of dimes look. It stacks more metal. It also helps flatten the weld out. So you have to remember, when you lift this up, you have metal that's kind of spraying out of this tip down, and that is going to allow it to kind of, I guess, spread out over a bigger area because your arc gap is bigger. When you keep a tight arc, the weld is going to tend to choke down a little bit. So when welding two plates in a flat position, doing this, and I'll show you actual, it's more like this. Okay, it's not like this, is a little exaggerated, but that's another way you can manipulate it. A lot of guys I know, I guess on pipe and certain, like if you're trying to fill a big gap, you can also do circles. What the circles allows you to do is make a wider weld and somewhat limit the depth of penetration. Because you're carrying the heat out over a wider area, your pool's going to widen, your penetration's going to slightly lessen, but you're going to deposit more metal over, say, a 4-inch, 3-inch long weld than you would if you just ran straight in like this, okay? So that's an option too. And I already covered this in my previous video about welding with 6010. 6010, and I'll mention it again now, is a low deposition rod. This flux does not contain iron powder or anything that really turns into weld material. So being an 1/8-inch rod, it really doesn't deposit much metal. And that's why it's so important. I watch people all the time when I've taught people to stick weld. They try and move with 6010 as fast as 7018. So they're moving like, kind of like this. And you don't want to do that with 6010. You want to slow down and just kind of manipulate it or run it straight in, but you're moving very slow in comparison to most other rods, okay? Again, you want to look at it, a good indicator that you're moving the right speed is when you clean off all the slag off your weld, if it's the same width as like your 7018 bead of the same rod diameter, you're doing it right. If you move too fast, your weld is going to choke down in width, and it's going to be less wide than a 7018. And I'll get a plate and show you guys. Apology in advance, this stuff isn't the cleanest. If you look here, and I'll try and get this positioned, that'll have to do. This was done with 1/8-inch rod at 6010, I believe it is, but it was done with 1/8-inch rod. This is 1/8-inch 7018 at varying amperages. You can see, and I'll just lay this rod here, pretty much the same width as that. It's very easy. If you try and travel as fast as 7018, your weld with 6010 is going to neck down even narrower than like this part right here. So you want to run your travel speed forward pretty slow with 6010. The last thing I guess I'll say, and then we're going to actually get into welding with it, is that 6010, if you don't have adjustable arc force, you're kind of at a disadvantage. Not to say you can't run 6010 without adjustable arc force, you absolutely can. But the whole purpose of the rod is really to give you more control over bridging gaps, welding over scabby material, and having adjustable arc force, which simply boosts the amperage the tighter you push the arc. You're probably going to run into issues where the rod's going to stick. It's going to be harder to start. Not only that, but your penetration and your heat input control is not going to be as good. So there is something to be said with having a welder with arc force control with running 6010 it just runs better. And the last thing I also kind of alluded to, and I didn't mention, but I just thought of it now. When you weld with 6010 and you go straight in, I find that it just does not weld as good. On an open route, like pipe or something, not a big deal. But trying to run it like 7018 or 6013, where you're just slowly dragging it, I don't know, it just does not seem to like that as much. And we'll see that in this video with the results. To start things off, I'm going to run 2 passes with the red 5P rod, and I'm going to try and run them just straight in with no oscillation. So pay attention at how wide and long the molten puddle is here. I'm going to run 2 passes, and I'll keep it in real time. I won't fast forward it. But when I do the other weld, you're going to notice subtle differences, besides the fact I'm manipulating the arc. So the plate is preheated from the previous pass. I did not cool it down between passes of each individual manipulation style. All right, so those ran no oscillation. I did not cool a plate between the passes, so the second pass will be flatter and wetted out better simply because of the heat input. So let me go and clean this and come back. So I cleaned this guy up, and this is what we have here. Ran straight in. It still has not a stack of dimes appearance, but you can see where it narrowed down, got wider. My second pass was a lot better. That's partially due to the preheated plate allowed everything to flow out better, and partially I was just, I guess, smoother. It also helped that I had a reference point to weld to, because once I struck the arc down here, I couldn't see this edge and I didn't scribe a line, so I just went blind. Fortunately, the bead is straight, just not straight on the plate. Whatever, mistakes were made. So when you look at this, every inconsistency in smooth travel that I had is reflected in the bead. Your bead, if you're learning to weld with 6010 for the first time or are fairly new, is probably going to look a lot worse than this. Like it's going to look like just a humped up mess of metal. And that's because you haven't developed the smoothness in how you feed the rod and your travel speed to get a bead to look like this. It's not a bad idea, rather than whipping and pausing and all the fancy manipulations with 6010, get to the point to where you can just run a straight smooth bead with it. If you can do this, you can do whipping and pausing and any manipulations pretty easily too, because it's actually pretty difficult to get an equal width height bead. I mean, you've seen my 7018 beads, and those things look, you know, like a laser, and they're the same height and width. I mean, even like these, and I wasn't even trying on this, but for the most part, very equal. This, not so much, and that's just because of how fast that puddle freezes on you. So these two were ran straight in. Now what I'm going to do is I'm going to run a manipulation that I personally prefer on flat plate, fillet welds, whatever have you, overhead, uphill to vertical up to a certain extent. And that's, I'm going to do kind of like a dig in motion and then back a little bit. Dig in, back, dig in, back. Inadvertently, as I bring it up, it does push the metal and flatten it out due to the force of the arc. So I'm sort of doing that. We're going to do 2 passes, and you're going to watch what happens with that. It's going to end up stacking like kind of like dimes. I'm not a big fan of calling it that, but it is going to have a distinct ripple pattern, and that's because I'm doing this. So we'll do 2 passes with that and then talk about the results. I ended up reshooting arc footage for this second set. The ones that I had just looked terrible. So from this angle, if you look at it, it looks like I'm just moving forward and back. I'm not actually just moving forward and back. I'm manipulating the rod sort of in an arc up, and every time you see it get brighter, it's because the arc length is increasing. You'll see it a little bit better in the next arc footage. All right, so we have a lot different results. You'll have to apologize, or I will have to apologize for not running straight beads. Imagine that. Welding around a camera is pretty difficult. So our first bead straight in, not good. I'll take the credit for that one. Second one, more consistent in width, still not really that good. Now when you look at this with a slight manipulation, now mind you, this isn't straight. I could have done a better job there. But if you notice, other than right here, I mean, this bead and this bead, like the width is more consistent, I would say overall than what this is, definitely what this is. Not only that, but it's wider. Clearly, now this was run after that was welded. I cooled the plate down and then both of these, but you can see it's wider. And the reason is, as I'm bringing it and digging it down in and then arcing it, kind of rounding it back, that arc force is pushing and widening out the molten metal on the top, which makes it wider. If you just go straight in, your beads are always going to be narrower. And that's what I find to be the case pretty much universally with 6010. The other interesting thing is, and maybe the video says something otherwise, but to me, operating this, there seemed to be less spatter running it like this than there was here. To me, you know, I don't know, the manipulation seemed to make it run better. Now let me turn this over here and I'll tip it to where we can look at it better. Again, not the straightest of welds. I purposefully stopped right here, and then this, I pretty much stuck the rod because there was very, very little left on it. But I want to show you, it might be a little difficult to see. Let me try not to burn my hands. Let's see if I can get this positioned. Oh, bump the camera. Yeah, it's a little bit hard to see. When I'm welding this, I tried to leave a crater of sorts, but when I come down into here, I can literally see an edge of the base material, so the surface here, and then it's like undercutting into that. I can see it sink in. You see a little bit of it here, because that is, yeah, you can see it there, how that's below the surface. So it's kind of like you're gouging into it. However, if your travel speed is slow enough, you will fill that. If you go too fast like this, you're going to gouge out and basically undercut your material, and you're never going to deposit enough to fill it. And that's kind of a good way, now that I think of it, to describe what you're doing here, is you're literally undercutting the plate, and then you're going slow enough to fill up the undercut that you made, which gives you a tremendous amount of penetration. Like, this is only at 90 amps. If I crank this sucker up to 110 with, you know, a 65-75% arc force and really push this in there, I could probably get halfway through this 1/4 inch plate for penetration. I'll have to shoot a video on that coming up next. But you can see, again, it seems to run better with manipulation. This is one manipulation. And again, I'll just give you a demonstration here, and I'll exaggerate a little bit. I'm like this, up a little bit, And I'm kind of almost, if you look, just rocking it like this and just slowly moving forward. That's it. And I do let the flux of the rod touch the metal and almost dig in there. If your arc force isn't high enough, the rod will stick. If it's high enough, it won't stick. And that's pretty much what I tend to do. It works really good. We're going to attempt to do what I would call kind of a, I don't know, forward and long arc. This works good for trying to fill a gap, because when you long arc it, the arc ends up spreading out over a larger area. Ooh, that's hot. Which cools down the exact area underneath the rod a little bit. So by bringing it forward, or bringing it forward, back, bringing it forward, back like that, it sounds crazy that as the arc gets longer and there's actually more heat, it's just that the heat is less concentrated, which gives the molten pool time to solidify. So I'll do 2 passes with this movement. I don't do it very often, so I'm not really that great at it, but we will do it. I have a feeling if I had to make a prediction, it's going to make a slightly wider weld than this, and it's also going to make a more distinct ripple pattern than this. So this is kind of like, you know, it's got a stack of dimes to it, but from this angle, not so much. This definitely more consistent, but I believe we're going to see a more distinct ripple pattern with this movement. So let's get into it. All right, so did 2 welds again. Not quite as distinguishable dimes as I would have expected. I guess so. I mean, if you look at it, the spacing is wider on them, which would make sense because I'm progressing further forward. I deposited less metal. We might be able to see it on the height. These are almost a little wider actually too. I can tell I deposited less metal with these two, so my travel speed was a little higher. The reason I say that is I was able with 1 rod to do 2 welds. With 1 rod with these 2, I did not make it to the end. So I do know that I deposited less metal simply because of how many rods I used. From a standpoint of appearance, minus again, not a straight bead, imagine that, this one's a lot better. They look pretty good, very similar to these guys. I probably exaggerated my like stitch or my arc gap a little bit. And that's somewhat, you saw, I mean, it made a decent looking weld, but I could have just moved forward and only long arced it a little bit less than what I was doing. But hey, it worked and it looks pretty good. You also see at the end, one of the things is with 6010, it's very common, not so much up here, I didn't do it in these, I didn't make it to the end of the plate, to get porosity, and I wouldn't even call this porosity, it's just like a cavern due to not holding the end and then coming back through to fill that. So I snapped out of the arc, and because that molten metal is so fast to solidify, that there was still balls of molten metal coming off the rod hitting this, and it essentially forms like a crater, much like an asteroid hitting the Earth. So I believe that's what you're looking at there, simply molten metal dripping off the rod into this pool, and it solidified so fast it just captured that. So to avoid that, you want to keep a very tight arc at the end and then maybe weld backwards a little bit just to make sure that's filled up and hot enough to where it caps that without leaving it. Yeah, from a standpoint of just looking at it, and I'll turn it over here so you can get a little different lighting on there. Not bad. Definitely not as, smooth as your 7018 beads, but that's 6010. That's how it should look. I mean, that's kind of what's to be expected. There's a couple of other things I'm going to mention here. One is, I know that most of you guys out there are home gamers, and talking about stuff far beyond that may not be of too much use to you, but I will mention when you do welds with 6010 on pipe and, I don't know, plate, if anyone really does that anymore, it's primarily used for pipe and just in-field use. It's very common, like on pipe, to do an x-ray after you finish your welds, and it might even be done between every couple passes, hard to say, but definitely at the end of your job for a particular weld. Well, if you look here, you see this line here along the side of the weld? This one had it really bad. That's still slag in there, okay? When you do multi-pass welds, and say you had to do 2 wide, you did a root pass 2, and then you had to do 3 more over that, if you just come in here and weld right over this, especially with 7018, you can entrap that slag and you get what's called wagon wheel tracks on the x-ray. You basically bust x-ray because down the whole weld, you'll see a line that follows this because you don't burn this out. Now, if you're doing multiple passes 60-10, you probably will burn that out, but it's hard to say. So my recommendation, and I wire wheeled this on a grinder, and you can see it left this here. And I'm gonna show you that that does come off. The best way, there's a couple ways. Let me get a couple tools here and I'll be right back. So you get a couple ways to get rid of those wagon wheel tracks there. One is to take a slight grinder disc like this and literally just go down the edge and buff it. A very light, quick buff will clean that right out, and then you can weld over the top of it with no issues. Another option would be to use a chipping hammer to get that, and I'm going to try and do that now. It's a little hard because the plate isn't bolted down to the table here, and I'll brush it a little bit. Let's see if you can see it. I cleaned off some of it right in there. There's still a lot in here, okay? Let me try and brush this. If you use a brush like this that comes to a point, this is a fillet weld brush. It's a little worse for wear, a lot worse for wear, but it comes down to a point. That allows you to really get in there. All right, see how much more I cleaned out of that? I mean, there's still some on there, but like in here, much better than this side. When you start looking at these, you see all that? You don't want to leave that, especially like when it gets thick like that. I'll brush, let me brush this one too, just to show you. Yeah, angle grinders with wire wheels don't tend to get in there that well. It's a little bit better. Not perfect. Little bit, but do what you can to get that as minimal cleaned out as possible. You don't want that. All right, well, at this point, I think what I'm going to do is I'm going to cut this plate down in half, and then I'm actually going to cut this, and we'll do a cut and etch and just look if there's any real differences in the penetration profiles of these. I don't really know. I have a feeling that the most penetration is probably going to be on this middle one, but hedge your bets now. Dun, 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 the results. I photo manipulated this a little bit just to bring out the details so there's no question. So number 1 was the first, just run straight in. 2 is going to be done with my preferred kind of like stitch with an arc. And then 3 was the lift and then long arc and then move forward basically. Now looking at these, you can see that the second weld, which is the one to the right of each number, 1, 2, and 3, has more penetration than the first one. And that's due to the plate being preheated. Since each 1, 2, and 3, I welded the first one and then the second pass right away without cooling it. I only cooled it between each rod manipulation set. So there's definitely more penetration on the second. Also, the penetration between the first and second, so no manipulation in the sawtooth that I do kind of, seems to be pretty much equal. The third one seems very close, slightly less maybe on the last one, but I would say these are all so close, it's hard to really say that one is absolutely better than the other than running it on a hot plate is better than a cold plate. Not really, I guess, what I expected, but the manipulation, I have a feeling, will change depending on where you're looking in the plate. So I could saw this plate 10 more times and see slightly different results. I think the good takeaway from this is that 6010 has very good penetration, even on thicker plate. And at 90 amps, had I cranked it up to 110 maybe, that all of them would have penetrated even deeper. So I would say these are all a pass. One thing too, I didn't even mention, the number 3 seems to be a flatter bead profile. If you look at it, that long arcing really seems to flatten a bead, and we'll look at it in person now. So here are the test plates that we ran. I did run a couple of the extra welds to get arc footage because it didn't turn out that well. But I wanted to take a look here. So these top 2 are going to be the straight in. These 2 are my kind of sawtooth oscillation, and then this is the straight lift, straight lift. It's hard to tell. These 2 are flatter. The weld profile is almost square. When you look at these, they're a little bit more rounded. Same thing with these 2. And you can actually see, it's a little rough here, you can see the profile. So a little colder, hotter plate, but flat, even flatter. So I will say that that stitch and lift, that really flattens it out nice. So if you're looking for a flat bead overall, that might be the way to go. This definitely gives a more crowned up weld, and straight in is super crowned up. I mean, you can just see that. Yeah, I guess I learned a little bit here. Not quite what I expected, like I said, but I mean, I feel confident in telling you guys that how you manipulate it is probably going to be all right. And I know that if you're trying to bridge a gap like this, you're going to have to manipulate it and use the fast freeze to your advantage. And I actually have a video coming out in a few days that will show that, where I'm going to uphill weld a gap probably pretty close to this. And in that, you're going to see how stitching it and oscillating is going to give you a huge advantage to fill a gap and actually be able to weld something, versus most other rods will just get so hot that the molten pool will drip. So with that said, thanks for sticking around. If there's any ideas you want to see done, leave them in the comments section. Otherwise, I appreciate it, and until next time.